Okay, now what we want to do is to use a switch to control an LED. So I'll just select my switch because I've rotated it. I want to rotate my switch as well. And then I'll put the switch across. Notice this side is connected to that side is connected. So when I close, it closes that way. Now for the switch, let's put the switch down because we want to connect the switch to pin 2. So let's say you have a switch, connect to pin 2. You have to be careful when you use pin 2 because pin 2 is the interrupt pin. Double click, create a new. I like using black for ground, so I know where that is a ground pin, and yeah, normally red, but let's pick something interesting. Orange. An LED because we want to visualize it. So take the LED, I want to rotate it, I'll press R. Remember the LED, the long one is the anode, and it's the same for the physical LED as well. The short one is the cathode. So we drag and drop the LED. 2 is to connect a resistor to the anode, and then from the resistor we want to connect it to pin 5. So we get our resistor. It's a reasonable resistor and it's affordable, or we can actually find them in the market as well. And from the resistor, we want to connect the anode to pin 5. Shall we label it orange as well, or something funky? Pink? Too bright, but that's cool. Now let's set it to the color of the LED. What color shall we use for the LED? Yellow? Cathode to ground. Ground, let's label it black. What we want is to blink the LED with a switch. And remember, this is digital input, and obviously we can either do an analog or digital output to the pin. Now press the code and you select text only. So you want to select text. When you click continue, that will create this for us. Two things we know we need is the setup and the void loop. So what I want to do is to clear this to have only the setup and the void loop. Right now, if I run it, it will run without any code because there's nothing to do, but it doesn't give us errors. So we have the setup and the void being reasonable for the Arduino to work. What I would do is to bring out the Arduino IDE. Now, if I run this, just the void setup alone. Now you notice that just the void setup and the loop function alone, we're already using 444 bytes of memory. To get it to work, we define a few variables. So we just use const, define an integer variable called button and assign it to pin 2. Then we can define another constant integer variable called LED pin, and we want to assign that to pin 5. The LED, because the LED is connected to pin 5, and the other is the push button because it's connected to pin 2. If anybody doesn't know what any function means, you can go to the Arduino reference. If you search for Arduino reference, you've got all the functions there for you to catch up the functions more. So the pin mode function, you can use it to set pin as an input or output. So here the button pin. Button is an input because we are reading from the push button. But we want the data sheet. To the I/O port, you notice that each pin can be connected to a pull-up resistor. So to make life easy for us, we connect the switch to input it up to 5 volt. Chip itself, ATme3289P. In 13 is connected to the microchips port B5. On this side, in 13 on the board is connected by a 1K resistor to the yellow onboard LED to the ground, which is this LED. So we've got pin mode and we've got a button input pull up. And we also want to set the LED pin. So pin mode, want to set it as an output. And what we want to do is first of all, maybe declare an integer, a switch, the state of the switch. And I have said, if you want to reference, basically go to the Arduino reference. But it's not what I intend to do. Go to the Arduino reference, do a digital read. And basically, I have explained this step by step in the catch-up videos, and please catch up, right? And that will be very helpful. So if you do a digital read on the pattern pin, if let's say the switch value of that switch is low, remember we've already set it to pull up, meaning before we press it, the value will be 5 or 5 volts, or it will be high. So and note the comparison operator basically is different from the assignment operator. So comparison, you use the double equal sign. Assignment, you use only one equal sign. The switch is pressed. We want to write to the LED, and it's a digital write. We want to set it high. Else, it's to switch the LED off, right? Digital write LED pin. Now you notice from what we did before that we had 444 bytes just by using the setup and the function alone. So let's copy and paste our code in the Arduino IDE to see how much memory we are using. It jumps from 444 to almost twice as much, so we start using more than 1% of it. So we end up using 892 bytes. And let's run the application. See, so originally it's off, If I press, it becomes on. I hope it's visible and you can see it. So if I press, it comes on, let go, it goes off. Press, it comes on, let go, it goes off. So reading and then putting out the circuitry. Just the setup, the loop function alone is using 444 bytes, which means any code we write is going to be at least 444. There are ways around it. The loop and the setup, the things that were added on top of the AVR architecture that I had as part of the Arduino bootloader to make things easy for to program. I'll stop the recording here.